People keep asking me, how can I get my grade up? Do well on this next test. That's literally it. The quizzes so far have been 10 points each. The test is 150 points. 150 assessment points. So yeah, just do well on this next test and you will see a big improvement in your grade. If you don't do well on this next test, I mean, we have a retake opportunity planned in class, but then other than that, like if you take that as well, then your grade is going to be bad until like the next unit test. So keep that in mind. I am not hiding what the questions look like. I'm showing you what the questions are through the study guides. You have two that are exactly aligned to the test. One that matches the 100-point portion of the test, and one that matches the 50-point portion of the test. When you test on Tuesday, you have to complete both parts in class. So like 10 online and like 4 on paper. Okay. Then you have this other one that is optional and extra credit. It says it in the title. That one is basically different every time you take it, but it's also closely aligned to the skills. I would say the first two are the most important, the ones that are required for a grade. And then the other one is just like, if you really want to make sure you're good. Okay, so any questions on that part? So if you're not used to taking things in a time setting, like know that you have the hour to finish those problems. I think that's a lot of time. But you have the hour to finish all that. It's not open note, so make sure you come prepared with all the stuff in your brain. There's lots of like study materials in Schoology, like, oh, I don't think I have a picture of it, but there's a glossary. You could make your own flashcards from it. Or you can just use the Quizlet that has a flashcards feature and it's already made. So I know it's a lot of vocabulary to memorize. But there's that. If you did not get a good grade for your binder check, and you'll see, because I will hope to post them sometime today. But if you did not get a good grade on it, you would definitely want to resubmit it. And should you want to do that, basically anytime I'm not teaching, you can show me your whole binder again, because I do not memorize your previous. You have to show me it all again, I count it all again, and then I update it. And I always put like in a little comment, how long you have to resubmit it. So just make sure you pay attention to that. If you didn't get full points, you should get full points. This is like not something that requires accuracy, which requires you participating in notes and not reading the notes. You can always review your notes if you're looking at it. All the pages are here, they're all online, you can do them on your own paper. Questions? Okay, so now to the study guides. What are we still confused about? If you're confused about it on there. Confused come test time. All right, I need to pull it out. No requests, you guys all are gonna face every problem. Nothing wants to work out or explain. On Monday, we're doing a Kahoot, so there's not really gonna be opportunities on Monday. I'm going to specifically remember to ask. So what do we have with now? Okay, so know that the first like 100-point study guide, the one that is not optional, is the same each time you take it, whereas the optional one would be different each time you take it. So you really only get 3 attempts on the first one because it's the same every time you take it. I mean, hopefully, if you needed a 4th attempt, we would know what the answers are because most of them only have 4 options. But should you also be struggling with that first study guide, the number 6 should be the same for everyone, right? It's not trouble. So here's number 6 on the first study guide. No one should have this one not done and not turned in. We are looking at this dot plot and completing the frequency table representing the data. You guys first saw frequency tables in the histogram lesson. Frequency tells me what about the data? Not how spread out it is. Sorry, what? How often something occurs. So yeah, like you can see from this table, the number 5 occurred 3 times. And then this, we have some blanks to fill in. What needs to go on this first blank?
All right. What needs to go on the second blank? All right, so we're saying the 6 occurred twice, which it did. You can see that in a dot plot. We're saying the 7 occurred 3 times, which it did. This is blank for the 8, so how many times did the 8 occur? So then you would type a 7 here. And then that saying the 9 occurred 3 times, which it did, and the 10 occurred how many times? So that's how you fill in a frequency table. That's how you read a frequency table. So if you're given a frequency table and told to match the correct dot plot, then you're saying that this is the data itself, and this is how often it occurred. Frequency is how often it occurred. Questions on that one? Questions on others? Could be from the paper, could be from either online study guide. But closed mouths don't get fed, so if you're just being shy, it's not gonna work in your favor. Massimo? Number 8 on this one? Okay, so the dot plots show the number of hours of video games played in a day by 2 students, Jerome and Sarah. Select all that must be true. So select all, what does that mean when you see select all? There could be multiple answers. There also could just be one answer, so you literally just have to check every single one and see if it's true, you select it. So, also, when you do take your tests, when I grade it, I give points for like the right answer is right, but then if you give a wrong answer, I do take half point of it. So be like really sure what you're picking is true, if that's what it's asking. So first it says, and these parts might be shuffled, so you just pay attention to what it actually says. The mean and median values for Jerome's data are about the same. So just looking at Jerome's, you would have to probably use a calculator for the median, or sorry, for the mean, because this is not symmetric. You can't just tell the mean just from looking at it. You could figure out the median from doing like your left, right. But since I already have to use a calculator to do the mean, I'm gonna also use it for the median too, because why not? So that's what I'm gonna do. And sorry, I can't see my mouse, so I have to do it from back here. We could even call Jerome's data J. That letter seems to work fine. And it looks like he has 5 zeros. You do have to put those if they are data points, because they would affect the mean and everything else. They have 4 1s, 3 2s, 1 3, 1 4, 1 5, and 1 6. So how do I make it tell me the mean? So go to functions, so click the keyboard, hit functions.
And then what? Okay, we're in the statistics unit, so you should see a lot of what you need here. Mean, and then whatever you called your data set. If I called it J, then I use the letter J. If I use D, then I use the letter D. People always forget this part and then they ask me on a test and then I can't tell them. So make sure you know your calculator in advance. So my mean is 1.75. My median, which is also in the functions menu, but I know the function by heart, so I can just type in median, parentheses, and then whatever I called my data. So are the mean and median for Jerome's data about the same? I'm gonna say no. I know about kind of gives some interpretation, like 1 and 1.75 is close, but like I'm gonna go with no. Okay, so no, they are not about the same. For Sarah's data, let's look at hers. Would you say that hers is symmetric? Maybe not perfectly symmetric, but I think what this is going for is mostly symmetric. I do think for hers, without doing the math, that the mean and median are about the same. But since that one is not perfectly symmetric, I could also just type it in. And confirm if I wasn't 100% sure, but we'll see. It's mostly symmetric, so I'm going to go with that. It is about the same. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So just making sure that this tells me the same number of data points I had, so I didn't miss any. And then for Sarah's, I use the letter S. If I want her mean, I'm going to do mean of Sarah's data and median of Sarah's data. So this is off by 0.75, whereas this one's off by 0.26. So I know that word about leaves it to interpretation. I think on your test, it'll be more clear, but I'm going to go with that. It's about the same for Sarah's because it's mostly symmetric. Okay. Now it says Sarah's standard deviation is higher than Jerome's. That one you should be able to tell without doing the math, but also know that I did already type it in, so I really could just continue using my calculator. But would you say that Sarah's is more spread out than Jerome's? Okay, I'm getting some mixed answers. Let's see then. So if I do standard deviation of Jerome's, his is about 1.8. If I do standard deviation of Sarah's, hers is about 1.7. So their standard deviations are close, so that's why some of you said yes, some of you said no, they are close. But whose is technically more spread out? Jerome's. So we're going to go with that. Jerome's is higher, so Sarah's must be lower. Okay. Again, it'll probably be more clear on your test. Now, the median values for both students is about the same. We already calculated the median earlier, so Sarah's median was S, Jerome's was 1. Would you say that? Not S. Sarah's median was 3. Jerome's median was 1. Would you say that's about the same? Maybe in like a really big scheme of things, like, yeah, those numbers are pretty close, but I think they're going to go with no, because this middle is over here and their middle is over there. So I'm going to go with that. They're saying no. The mean values for both students is about the same. So mean for Jerome is 1.75. Mean for Sarah's is about 3.26. So I'm going to go with no. If Jerome stayed homesick from school on Tuesday and played 10 hours, this would affect the mean value for him more than the median value. So that would be adding a data point on Jerome's way over here. Again, I can't see over there, so I have to do it back here. So 7, 8, pretend it extends like 9, 10. I'm adding a data point way over here. Would you consider that to be probably an outlier? What do outliers affect more, the mean or the median? The mean. Because think about like when you actually did the formula for the mean, that was when you had the sum of the numbers divided by how many numbers you had, so the number of numbers. Whereas the median is just your middle number. So when I add a number that's way bigger than the rest of my data or way smaller, that changes the top part more than, like way more than the bottom part. My mean will probably increase. Whereas my median, there seems to be a lot of ones there. It might not change at all. So this would affect the mean value more for Jerome than the median. I would say that's true. If Sarah stayed homesick from school on Tuesday and played 10 hours, this would affect the median for her. So it's not like which one does it affect more, it's saying it affects it. So for that one, I'd probably do the math, but I already had it typed up in here. And we're not taking away or changing a data point in Sarah's, we're just adding a data point. So now we're adding the data point 10. So now she has 20 data points. Her median before, let me show you in case you forgot, was 3. When I add that 10 data point, the median is still 3. So it did not change or affect it at all. Again, on your test, because I take your test myself to see how the problems are, I didn't need to do the math, but you could if you have time. And these are all right. So it should be these 3. It could be shuffled on your screen. So make sure you pick the ones that actually say the correct stuff. Good? Okay, other questions at all? Could be from the paper or the online. Don't be shy. I'm here to help. Like just in general? Okay, so standard deviation in general tells me what about the data? How spread out it is. So whenever I study, I try to think of ways to like memorize stuff. So you could think like standard deviation starts with an S. That's how spread out it is, right? Like just kind of think about it that way. Both start with S. There's other things that tell you how spread out the data is, like the MAD and also IQR. But note, like I'm kind of sorting it differently. Standard deviation and MAD both use the mean. At one point, you did calculate the MAD by hand, and it was pretty annoying if you remember, or maybe you still don't know how to do it. That's fine. You can use technology to do that. Standard deviation, we didn't bother teaching you at all because it's even longer than finding the MAD. So you can only find it with technology if you need to. Otherwise, if you can see very clearly that something is more spread out than something else, then you could say the thing that's more spread out has a higher standard deviation. Make sense? So what's the lowest standard deviation you can have? 0. You can't have a negative standard deviation. But 0 would be like if I had data, maybe like a dot plot, where it was all the same number. It's not spread out at all. On your tests, it might ask you, like if I add a data point over here, what does that do to my standard deviation? Does it increase, decrease, or stay the same? Increases, because now I'm changing how spread out it is. If I asked you, what does this do to the mean, what would you tell me? So mean is different. But if I asked you, what does this data point do to the mean, what would you say? Since I put it to the right of my data, the numbers to the right on the number line are bigger, it would increase my mean, right? So you have to be able to say things like that, and while you could do the math, you don't need to all the time. Questions on that? Okay, questions on other things? Often for the first time, I feel like kids always turn this, not all kids, but a good chunk always turn this part of your test in blank. There's no reason. So do we have any questions like on this one at all? We know what it means when it asks for like, what's the best measure of variability? What's the most appropriate for this data distribution to tell me a typical value? Like we all know what it's asking. Yes? Yeah. Like just from top to bottom, or is there a certain part? Okay, so then if you also didn't do 3 on your constructed response, maybe take it out and you jot down what I jot down. But we have a student that arranges students in her art class from shortest to tallest and measures the height in inches of each student. The height of the 20 shortest are in the histogram. And then the tallest 6 are listed below. So how many students are there total? 26. So 20 of them are already graphed for you. And then the other 6, the tallest, are listed here. So here's my 20 shortest, my 6 tallest. To complete the histogram, so they already set it up a certain way, you need to follow that same way they set it up. We know that histograms, by definition, like their y-axis is frequency. That tells me how often something occurred. So even though I can't see all the data, I know that from 60 to 62, that there was 5 people that fell within that margin, right? So know that. And each histogram bar should be an interval. So the way that they have it shown here, it's like the way that it comes out of a number and ends on a number. So like here's 64, here's 66, all that. Really in this bar is everything from 60 to like 61.9. As soon as it hits 62, it goes in the next bar. Because there's 2 ways they're usually displayed. But I want to include my tallest 6 student, so I kind of have to pick up where they left off. So this right here is 72. It ends on 74. So my next interval, if I want to keep it the same, like the same amount of numbers in each one, where would it end? Did you say 85? Well, I'm trying to follow like the pattern they have here. So like maybe if I add a few that they already had, so like they have an interval from 70 to 72, from 72 to 74, 74 to 76, right, would follow the next pattern. And then 76 to what? And then the way that they have it, it kind of overlaps, but if it was 78, it would actually go in this interval, right? Where would this one end? Where would this one start? Where would it end? Where would this one start? Where would it end? And where would this one start? And where would it end? Let me see if that's enough to cover the rest of my data, and it is. So this is like me making a frequency table. Here's my interval. And then I need to like jot down my frequency, how often something occurred from 70 to 72 and things like that. But look at my data that I'm supposed to complete. I have 79, like I'll do tally marks. So there's 179 that would go here. There's 2 80s. So which one does it go in the first one or the second one? If it's 80 exactly. Should be the second one. As soon as it's like the higher number in that bar, like where it ends, it actually goes in the next bar. So 80 exactly would go here. 83 would go here. That one's easy because it's in the middle of that range. 85 would fall into this range. And there's 2 of them. So when I do complete it, I probably shouldn't have written on this, but when I do complete it, I should have a bar coming out of the 78 to the 80, and it should just be as high as the 1 over here. I should have a bar coming out of 80 and ending on 82 that is as high as the 2, because there was 2 that fell in that range. 1 from 82 to 84, that's as high as the 1. And 1 from 84 to 86, that's as high as the 2, because there was 2 in there. You're welcome. So you're like finishing the pattern, if you will. After that, you're looking at the shape to compare the mean and median. How would you describe this shape? Is it symmetric? When it's not symmetric, you could say it's skewed even. But when it's not symmetric, are the mean and median equal? So you'd say no, and then you could explain because it's not symmetric, it's not equal, and blah, blah, blah is greater, depending on how it's skewed. The outliers pull the mean in that direction.